What's up, YouTubers? So as a little bit of an Easter treat, I thought I would do a couple flux core videos since I know a lot of you guys that watch my channel have flux core wire welders, and it's been a long time since I've done a video with it, and all my previous flux core videos never had any arc footage, so I thought I could do a little bit of update with arc footage and a couple more tips. So that's what we're going to be covering today. So let's get into it. All right, to start things out, we're going to be welding on a little bit thinner steel. We're going to be doing 1/8 inch, which is 3.2 millimeter roughly for you guys across the pond. And we're going to be using the Firepower FP200, which is a 200 amp MIG welder. So we're going to be using that. We are not going to be using a Harbor Freight Titanium 125. Now, the first thing I want to discuss is this weird sort of homemade nozzle. So the deal is with this, most MIG nozzles look like this, okay? There's ports in here, hopefully you can see those, gas ports, and your blend of gas or straight CO2 comes through the MIG gun, through this, and then out through this nozzle. Well, with flux core, since you don't run gas with it, you don't need this whole extended nozzle. Now, normally on most welders, you can just run without the nozzle on it and you're fine. And let me show you what I mean. With just like a thread protector or something, you can just run it like that. Well, the problem is this esab gun, and esab isn't the only one that does it, the tip is retained by the nozzle, okay? Without a nozzle on it, even though you technically don't need it, you're basically, nothing holds the tip in, not to mention you could get spatter on that. So esab does make a flux core nozzle for this. In most guns that are MIG guns, there are flux core nozzles available. The problem is I went to buy one for this and everyone was out of stock and it was gonna be forever. So all I did is take a standard MIG nozzle, cut it, and now it works the same. Now, at some point I'll probably braze shut the ports in here, but I just spin this to where they're not really aligned so nothing can get in there. I know it looks funky, but the benefit of this is that when you're down here welding, you can get this, if you look here, in here, and you have so much better visibility around the contact tip versus, let me show you this. You can't see anything in there with this. And for MIG, whatever, you have to deal with it, but with flux core, one of the huge benefits is better visibility of what you're welding. So when you look at that, like you have to do a drag angle, well, what can you see from the backside? Nothing. Versus you can see everything in there. So that would be if you can't get a flux core nozzle for yours, make one, do something. Trust me on that, it'll help with your visibility. And it is fairly common for me to weld where I'm staring at it from this direction and I'm dragging it this way, okay? Or I could be staring down here and dragging it this way. If you run a standard MIG nozzle, you have to essentially look at it from this way and drag it from here, which it just limits your visibility and options. So we're going to be welding with this setup because it's just better visibility, and we're going to be doing a couple joint styles, so let me get set up. So I got the welder fired up, and we're going to start out with something simple. What I'm going to do is simple lap joint. I'm going to tack this up. I'm going to get the camera set up, and we're going to look at the actual welding of this with some good arc footage. Here are my values. I don't know if you guys across the pond use centimeters per minute instead of inches per minute for wire feed speed, but it's 255 inch per minute, 647 centimeters per minute. Let me know in the comments if you guys use centimeters. Thanks. This is a wire I'm using. It's just E71T-GS. This is not suitable for multiple pass, so multiple layer. It's 030. And keep in mind, you must run this with your MIG gun on DCEN. if you have your MIG gun on the positive, like when you use normal MIG wire and gas, it's not going to weld properly. All flux core is welded EN on the gun. So let's get to doing some welding. So you can see my stick out's going to stay about the same all the way down. Very consistent, very straight. And you can see that molten puddle that's roughly the shape of like an eye or like an oval. I'm just dragging it along. I'm not doing any movement. So now I'm going to do a slight oscillation. And you want to pay attention to the top edge of that plate is kind of melting over. You can see the bead extends past the top plate. That's normal. My values here are running a little bit hot, so I'm burning up that top edge a little bit. So let's talk about this first weld here. And this sucker is still pretty hot. Now the first half, or 2/3 anyways, ran straight in. It was too hard to do any kind of oscillation. My values were definitely on the hot side. Now I just kind of blindly set the machine, and well, guess what? It was a little bit hot. I was able to handle it by keeping my travel speed extremely high, but I would prefer to have a little bit less heat and slow down just a pinch. Now the second run, which I didn't change anything, I just started and then basically ran it with an oscillation. You can see there's some porosity there. Now there's a couple probable reasons for that. One of which is when I started, I didn't wait long enough for the puddle to establish. My machine that I'm running on has what's called adjustable run-in, and I was fooling around with that the other night, and I don't even remember where it's set at, but it's probably a little bit off, so that gave me a cold start. And just so you know, for what run-in is how much wire it feeds, how fast at the initial half second or 1 second mark, and it's just to help prevent like cold starts. Well, a little bit off, and then I got moving right away, and guess what? The porosity there and the likely cause is gas didn't have enough time to escape out of that molten puddle before it solidified, therefore evidence of it is at the surface. Very common with flux core wire. My stick out may have been too short as well. I haven't looked at the arc footage, so I'm not sure. We'll be able to see in the arc footage. I would have mentioned it. But yeah, you can see there's a little bit of a ripple pattern, but you see how flat that is overall? I mean, there's some ripples, but they're kind of like elongated V's to a very sharp point. That's telling me high voltage, high heat input, high travel speed. So I'm going to reduce the settings a little bit and see what happens, and we're going to weld the other side of this. I slightly reduced the wire feed speed and dropped 0.2 volts. Not much, but it'll make a difference. Mistakes are made. I completely botched this, but I'm going to leave it in because just listen to the weld and how consistent it sounds start to finish. That's a telltale sign things are okay. I'm going to play this one twice, one with comments, one without. You can see a little bit lower of a value. It's not melting up over the edge as much, and I'm filling it right up to the edge. This is what you want to do. All right, so let's take a look at what we got. The first 2/3 I just ran straight in. With slightly colder values, I ran a little bit slower, and you can see the bead is not really crowned up, but it's a little bit more rounded. Let's look at that profile. See how it's a little bit more rounded? Not really too big of a deal. There's still some slag on the toes there. That'll all clean up. I just didn't get to it. When you look at this, It's got more of a flat profile. Now the restart where I had porosity on this one, we do not have that here, and that's simply because I left the wire long enough feeding into that area to get it to where all the gas was likely able to escape. Now my tie-in could be a little bit better. I should have started where it was, brought it over a little bit more, then welded through. I still have a little bit of work to do on the start of that as well, the run-in. So I'm not gonna adjust that, I'll keep welding it, but the run-in speed could be changed. That's looking pretty good, and this is kind of what you would expect from Flux core. Now, if I wasn't welding around a camera, I could actually do a pretty nice looking weld that you wouldn't really be able to distinguish from being MIG. Like Flux core process can produce some really good looking welds. It's just everything's gotta be right. And like I said, welding around a camera kind of sucks. So anyways, let's move on. This is looking decent. Let's go and do a fillet weld. These are the same settings as earlier, so no change. This shows an oscillation. You don't have to do that. I find that if I move forward, it bites into the root, and then I let it fill for a second. It just seems to work good and makes consistent welds. My tie-in went better here. I went backwards, filled it in, and then moved forward. But you can see that's the molten puddle. You just want to drag it slowly. If you don't oscillate, just drag it slowly along and let it fill. So let's take a look at what we got. The first half, I kind of did an oscillation, not a weave. A weave would kind of be more like up, down as you're progressing forward. I would call this an oscillation. Turned out pretty good. You don't really want a hugely distinct stack of dimes with flux core where it's like very tall dimes, because in order to get that, that means that you have to be running on the colder side, and you really don't want to run welds cold because you're going to lose penetration, but that's pretty acceptable. Then the second half I ran straight in. You can see that my tie-in was quite a bit better than the previous ones. It's a little bit tall there, but much better than like you saw this one where it didn't tie in, and then this one where again missed. So we're getting better there, that's a plus. There's still some flux on the toes. Let's look at the profile of this. Yeah, that's looking pretty acceptable. If I can get it to focus here. There, sorry about that. Not really roped up or anything at all, so the slightly lower values seems to be doing pretty good. I'm liking what I'm seeing. This is progress. Now, if you notice, there really isn't a whole lot of spatter with this, and that's partially because the settings are close to optimal, and not only that, I'm using a decent wire. Like I had said earlier in the video, I'm using this US Forge wire. It seems to have lower spatter. It is a -GS, so it's not suitable for multiple pass or really for structural stuff, but for gluing, you know, practice pieces together in general purpose, it'll work just fine. All right, well, why don't we, I guess, do another fillet weld, and I'm gonna try and focus on running it start to finish and making it as consistent as I can. I'm gonna have the camera zoomed out a little bit further because I think that'll be a more accurate representation of you actually welding this, because let's face it, how many of you are watching it this close while you weld so you can see it as in good of detail as the previous arc shots? Well, not many of you. Hopefully you don't want to have your head in there. So I'm going to set it up to where it's kind of like a realistic distance so we can look at that. So this is a little bit more realistic to what you might see. The main takeaway here is watch how close that contact tip is to the molten puddle and how that stays very consistent start to finish. That's very critical. I have a slight drag angle, maybe 20 degrees. My stick out from that contact tip to that molten puddle is about a 1/2 inch to 5/8 of an inch, very consistently. And my travel speed forward isn't really that fast, but it's very smooth. I'm not really picking up massive speed or slowing down. The weld is also staying the same size. That pool isn't changing shape and length or width. This is the same footage, just watch it without my commentary and pay attention to those things. So let's take a look at what we got here. I had the camera a little bit zoomed out further and just ran a bead start to finish. The profile of it overall is good, I would say. There's still some slag in the crack there in the toe, if you can see that little white powder. That's where, and I've shown this before on other videos, a fillet weld brush like this, which if you look, they come down to a point, really helps out at cleaning in there, because a normal brush that's wide, you know, it ends up cleaning up here and down here and not in there, and you can see how well that fits in there. So get one of these if you weld with flux core, lifesaver. So anyways, looking really good. The profile of it, I would say fairly flat, slight crown, and that's okay, slightly rounded. It definitely is nowhere near a bead on caulk, so this is all very acceptable. The width of it start to finish looks good, and if you notice, a real good telltale sign that your values and settings are really in the ballpark, very minimal spatter. I very quickly hit this with a wire wheel on a grinder, and there's like no spatter on it, so that's a very good sign as well. Looking really good, and this is about what you can expect out of flux core. I mean, it's not really a bad looking weld at all, and it's definitely going to be strong. So I thought what I would do to finish this video up, even though this is fairly thin material, is I'm going to cut it in half and etch it, and we're just going to look at what's going on. Now keep in mind, had I just increased the values a little bit more, I could have burned through this no problem, but we're just going to correlate what our welds look like to actual penetration. So the proof is in the pudding, and this is a pudding. The first pass is the one on the lower left. If you can notice, the top edge of that, which is the bottom in the picture, is melted off, and the bead penetration kind of has a weird taper to it, and that's simply because my values were high enough that the heat input melted that off and turned it into weld. You do not see that in the upper right because it wasn't hot enough to melt that off. The penetration between the two of them is practically identical, so really no issue there. It just looks like it's more on the lower left because it melted off that top edge. I like the slightly colder values and going a little bit slower. The bead is better looking, but it's not really a big deal either way. Now the two fillet welds I did have a little bit different of results. Now on the right you can see the penetration isn't as good as the left, and I can tell you my theory as to why. Where I cut the plate in half is literally right where that restart was on that right side, so I think the bead just didn't have enough time to heat up the metal to get better fusion, which is going to be typical and is a great example of why you want to minimize your starts and stops, because you run the risk of slightly less penetration at a restart in that general area. But beyond that, the one on the left was run pretty ideal values. They both were actually run at the same value. It's just the one on the left was start to finish the whole weld. very good penetration. Now, being that this is only 1/8 inch or 3.2 millimeter material, had I turned the welder up, the settings for like 1/4 inch, it would have just melted right through that plate. So having a really big weld that was run hot really isn't necessary on this, because a 1/4 inch settings, although it would have burned a hole through it and fully fused it, the weld would be, 50% bigger than it would need to be, excessive warping. You would have, the plate wouldn't stay at close to 90 degrees. You get the picture. So yeah, this weld size-wise is more than acceptable for a single pass. You would definitely not need to go back and do an additional pass. It's actually a little bit over what you would really need for this thickness of material, but that's fine. So yeah, there you have it. And I wanted to show you here where I was talking about how I cut it right in half, right where the restart was. If you look at that, that was literally right where it was at. So it doesn't surprise me that the penetration that you saw in that picture was a little bit less. I have a feeling the rest of this is all the same as the other side. And that's to be expected. The other thing I wanted to show you, I got a fillet weld gauge here. Now this bottom plate's a little bit bent, which is going to throw it off a little bit. But you can see how that weld is a little bit taller than an 1/8 inch. Or 3.2 millimeter, and then it's also just slightly taller or wider. So this weld essentially is a little bit over the required size, because not only is it as thick as this plate is, but it also has penetration beyond that. So for a single pass weld, you would never need to make a weld bigger than this on 1/8 inch material, because you can keep adding weld. Like I could put 2-3 more passes on this and it's not going to be any stronger. And the reason is that, well, this is only 1/8 inch material, and having, a 1/4 inch or 3/8 thick weld, what good is that going to do? It's going to be strong at the weld, but the material will fatigue and break. So overall, I'm pretty happy with that. If you wanted to make a little bit smaller of a weld by dropping the wire feed and the voltage a little bit more and moving a little bit faster, may help with that, but realistically, there's not really a need to do that. This is perfectly acceptable and is very strong based on the penetration of that. You definitely won't have any weld failures on that, especially for, standard stuff you'd use flux core on. So yeah, anyways, thanks for sticking around for the video. Hopefully you learned something. I know I always do when I do this stuff, and I know in the future I'll be able to reference my own videos because I can't possibly remember all of this stuff. So anyways, thanks for sticking around. I appreciate it. Until next time, guys.